Hello everybody, so today I will apply the calculus to find and analyze the curve and the graph in here. Question number 1. What point of the curve y equal to x power 4 is the normal line parallel to 2x plus y equal to 3? So in this one, we need to find the equation of the y. So we have the equation of the y is about, we move the 2x on the right, so you got about the minus 2x plus 3 because they are parallel. So that if we want to find the normal line of this curve, so that the first derivative should be the same of the minus 2 in here. So because they parallel, so that's why the coefficient of this line is similar of the first derivative of this curve. So that's why, so that we have first derivative equal to minus 2. First derivative of this curve is about 4x power 3. In this one, we put the minus 2 in here. And s power s is about minus 1 cubic of 2, cubic root of 2. So we have the formula of the tangent is about SO is about minus 1 divided to the cubic of 2, and YO is about the number we put from this one, put in here. So we have the first derivative is about minus 2. So this is the minus 2. S minus 2, this number, so that's about positive. And the next one, YO in here is about x power 4, so you have this one. So the next step you can do by yourself, multiply minus 2 with s, this number, and find the number. So this is the point, the tangent line we need to find. And if they ask what is the point, you just have the s in here, you put in this curve, and you got about the y. This one you can do by yourself because that's just so simple for you. The next one, find the point of inflection and critical point of this curve. The inflection point is about the second derivative. Then you put to the 0. Critical point is about first derivative, and you put to 0. So we do first derivative. First derivative of 5 is about 0, minus 2s is about minus 2, minus 3s power 3 is about minus 6s, and the minus s power 3 is about minus 3s power 2. Because we find the critical point, you put first derivative equal to 0, so this one will become the 0. And we got about s is minus 3 plus square root of 3 divided by 3, and minus 3 minus square root 3 divided by 3. So that if we have the s, you can find the y by you input the s in this equation similar this one. The inflection point is about the second derivative from the first derivative. So the derivative of minus 2 will become the 0. Minus 6s it will become the minus 6. Minus 3s power 2, and we have minus 6s in here. So we put to the 0 because we want to find the inflection point. Minus 6s equal to 0. So we got about s become the minus 1. So after we got about s equal to minus 1, you put in this equation and you find the y. So that's the point we need. You can do by yourself. Question number 3. Find the angle of intersection between two curves in here. So we had a tan phi is about the angle we need to find. The formula is about first derivative of this one minus first derivative of the second curve. Then we have 1 plus first derivative of number 1 multiplied first derivative of number 2. And in here, we need to find the intersection first. We have, if we want to find intersection about two equations, we put the first equation equal to second equation. So we have s power 2 plus 1 equal to s minus 1. S minus 1 is about 1 divided to s. So now we have s and 1 over s. We do about multiply with the s. Why we need to multiply with the s? Because s power 2 divided by s, you got about s. And this one is 1, sorry about that. So after you got about s power 2 plus 1 divided by s, you move the s on the left, you got about s equal to s power 1 plus 1 equal to s power 1, s power 2 plus 1. Then you move all them to the left, you got about s power 2 plus 1 with s minus 2 s power 2 plus 1 equal to 0. And then we have common factor in here, and we have s power 2 plus 1 and s minus 1 equal to 0. So in here they will become 0, but we have s power 2, so that we don't have the solution in this one. The next one become to 0, so we have s equal to 1. So that we need to find the integral between s equal to 1. So first derivative of the first one is about 2s. First derivative of the second one is about 1 minus 1 over 2s power 2. Because first derivative of 1 over s, it become the minus 1 over s power 2. So now we put in this equation. We have first one is about 2s minus 2. This second equation is minus 1 plus 2 1s power 2. And here we have 1 plus 2s multiply with 1 minus 2 1 over 2s power 2. But we have s equal to 1, so we put 1 in here, and we got about 2 minus 1 plus 1, and we have 1 plus 2 multiply with 1 minus 1. So that after we calculate everything, you got about 2, and we find phi is about tan of 2. Tan of 2 is about 63 by 43 degrees. So this is the answer for the question number 3. Question number 4 is so long a little bit because they asked 3 things. That's about the radius of curvature, center of curvature, and the curvature. To do this equation, we need to have the formula. So we do y equal to s power 4 minus 2s power 2. We separate 2 by because we need to do the second one. We have the s and y. S and y is about the center of the curvature. I want to do this one, and the formula is about s minus 2 first derivative of y is about this one plus 2 first derivative of y power 2. Then we will divide the second derivative. About this one we have y plus 2 1 plus 2y first derivative of y power 2 divided to second derivative. So they ask about at the origin, so that's about 0 and 0 in here. First derivative is about 4s power 3 minus 2s. Second derivative is about 4s power 3 is about 12s power 2 and the minus 2. So we have 0 and 0, so that s is about 0, y is the first derivative, they will become the 0. So you got about the 0 in here because this one is about 0 on the first derivative because we put 0, that's why it becomes 0. Y will become the 0 in here. This one is about first derivative of y, it will become the 0, so we have only number 1, so we got about number 1 in here. On the second derivative we have the 0 in here, so you got about the minus 2, so the y the minus 2 in here. So the center of the first question is about 0 and the minus 1 over 2. The next one we will talk about the curvature. Curvature, we have the formula we call them is about capital K. In the capital K we have the absolute value of the second derivative divided to 1 plus first derivative power 2, and the power is about 3 over 2. In the second derivative you got about the minus 2, but we have the absolute value, so that will become the number 2. First derivative in here we put about 0, so we have only 1, and you got about 1 in here. And the curvature is about number 2. The radius of curvature in the question they mentioned, they will have r equal to 1 divided by k. We have k is about 2, and we put 1 divided by 2. So the answer of the radius of the curvature is about 1 over 2. About y power 2 equal to s power 3. You do put about the square root. It's about the square root of s power 3, positive and negative. So now you will apply this formula similar on the top one, and you can answer for you.